Hey everyone, Matt Lewis here. This is Advanced VPC Design and New Capabilities for Amazon VPC. We've got a whole bunch of content here to cover with you folks today, but the main purpose of this session is to take a little step back in time. We're going to go back to about November 2020, or November 2019 actually, and then we're going to build upon all of the new features that we've released over the last 12 months or so. So we've got lots of exciting stuff to chat about here. And again, Matt Lewis, I'm a Principal Solution Architect over here at Amazon Web Services. All right, so let's take our step back into time to November 2019. And I actually have a quick icon here for you folks. This is actually the original VPC icon, and I think it's actually in the original Jeff Barr announcement blog post for VPC. So I always think it's interesting, make a bunch of this content and to see the progression of different icons on different services and that sort of thing as we go through time. So there's the original for you folks. Okay, so what we're going to do here is we'll build out an Amazon VPC and just talk about what the different constructs are and how they kind of fit together in an overall architecture. So we have Amazon EC2, and I always use EC2 as the base level service, just because a lot of our other services are built upon EC2. So if you understand how EC2 works, it's really easy to then transfer that knowledge to other services like RDS and EMR and others and understand how they work as well. So we've got an Amazon region here, and we have 24 regions worldwide. And inside the region, we have an Amazon VPC. And a VPC is a region level construct. So it spans the whole AWS region. And so a VPC itself is basically a CIDR address range. Here we've got a 10.100/16. You choose that range. We can expand up to 5 ranges for the VPC. And we can also use IPv6 as well within the VPC in dual stack mode. And so what we have here inside the VPC are availability zones. And availability zones are essentially groupings of fault domains within the AWS region. And you deploy in these different availability zones when you're spinning up things like EC2. And to do that, you actually use subnets. So we've created 4 subnets here. We've got 2 public and 2 private subnets. And then within those subnets, we've got EC2 instances. And so we've got instance A, B, C, and D. And you'll notice that they each have an address out of the VPC range, but we've created a subnet for each of these instances that we've created. So we've got a 10.1.0/24, for example, for instance A. Now, outside of the VPC, we have a whole bunch of other services. So S3, DynamoDB, SQS, SNS, Lambda. These services, and there's many of them, sit outside of the realm of the VPC, but you can also bring them in and connect them to the VPC, which we'll talk a lot about today. We also have the public internet out here on the outside of the VPC. And if we want to build connectivity here through to the public internet or maybe to one of these services, we actually use routing. And so we've got route tables for each of these subnets. And we've got a public subnet and a private subnet here that we're looking at. And the difference is the public subnets actually have a default route to the internet gateway or to the internet, whereas a private subnet does not. And so what we're going to do here is add an internet gateway. It's essentially a NATing function that allows you to connect to the internet. And we'll build our default route for the instance A in our public subnet. And we also need to add an elastic IP here, which is essentially a public IP from Amazon's range. You can bring your own range if you like, but now we've built internet connectivity for that instance. That instance can reach out to the internet and the internet can reach down through to that instance. Pretty straightforward. Now what we've also got here is for our private subnets, we've got a default route via an instance, and that instance could be a NAT instance which is doing port address translation. And so we send traffic to the instance. That instance does a source NATing and sends that traffic onto the internet gateway. You could also use NAT gateway if you'd like in that availability zone. Probably a good idea because managing NAT instances can be a little bit complex at times. So we have a route to the NAT gateway and we have an elastic IP. So now we have a base level VPC that shows you how to connect to the internet. What we're going to do here is layer on in a pretty quick fashion too, just in the interest of time here, we'll show you a macro view of all of the things you can add to a VPC. So we have gateway endpoints where you can connect to DynamoDB or S3. We have a VPN gateway where you can connect VPN and direct connect. We've got VPC peering to connect many VPCs together in a point-to-point fashion. We've got transit gateway, which we'll chat about, that can connect up to 5,000 VPCs in a region. We've also got things like a transit VIF that we'll talk about, VPN termination on a transit gateway, and VPC flow logs. And you'll notice on the left-hand side, we're building out our routing as we go along. And that's definitely important. When you add these new services, you need to build the route tables accordingly. And so then we have PrivateLink. We've got a couple of slides on PrivateLink, which we're going to chat about. Traffic mirroring, so you can take packets from your instances and send them to a monitoring instance. Edge gateway route tables, we'll chat about briefly. Client-to-site VPN, and here Outposts, which we have a couple of slides on as well. So Outposts is extending that VPC down to your on-premises. Pretty exciting stuff. Lastly here, we've got Global Accelerator, which is an Anycast-like service that has a whole bunch of other technology built into it to front-end your region or regions. But overall, this is really the high-level view of a VPC and before the changes that happened since November 2019. So what we'll do now is we're going to take a dive into each one of these services as we go along, and we'll talk about what's changed, or we've even got new services here that have recently announced. Now, up in the top right-hand corner, we've also got some QR codes and a link. Feel free to grab your smartphone and just take a photo of the QR code, and it should prompt you to take you to the link to learn more information about each of these services. So for PrivateLink, we'll start with interface VPC endpoints. So how interface endpoints work is we've taken a whole bunch of services and we're using PrivateLink to drop those services privately into the Amazon VPC. And so what happens here is we don't need any more routing, which is actually pretty awesome because we're already managing all of the routes for all of those other services. But here we take an Elastic Network interface for each service, or a set of Elastic Network interfaces for each service, and you can reach those privately from within the VPC. And so before November 2019, we had about 41 services that supported PrivateLink, but we heard overwhelming feedback from our customers that you folks really like the VPC and the private area that gives you, but you wanted to drop more services into the VPC. So what we did was we basically built PrivateLink for a whole bunch more services, and we actually have 99 plus services now supported with PrivateLink that you can drop into the VPC privately. And so that's actually changing as we go along. You'll notice one of the screenshots I have here has 95 listed, and we actually have 99 now. So even as we're going along and I'm presenting this, we're adding more services to this. Now, you can also do fine-grained IAM policies on those interfaces, which is great. And let's just jump into the console really quickly here to show you folks how to create an endpoint. So we've got the management interface, our console. We jump down to the VPC here on the left-hand side and go to endpoints. Now, when we create an endpoint, in this case, we're creating an endpoint to an AWS service, and we essentially select the service that you'd like to drop an endpoint into that VPC. Now, you'll notice here we've got 1 of 50 of 93. That number is even higher now, which is awesome. So you can use all of these services privately within your VPC. Now, there's another type of interface endpoint that we have, and that's for endpoint services, where essentially we took the technology for PrivateLink and we enabled it for you folks to use. So essentially here we've got an endpoint that is fronting a SaaS provider's service, or maybe your service inside a service provider VPC, and you can then drop that endpoint into the VPC. You can also reach that via VPC peering. And this is also applicable for interface endpoints too. You can reach that via peering as well. Now, some of the updates we did, we now have over 450 partners that offer endpoint services, and you can subscribe to these services. So a huge amount of our partners that have built these services. We also have private DNS names and fine-grained IAM permissions as well. A couple of QR codes there in case you're interested in both of those features for private DNS names and private IAM permissions. Now, this is an exciting one. This one actually just got released pretty recently, and S3, along with DynamoDB, you would use a gateway endpoint to access the service. So here we've got an S3 prefix list, so you need a route to S3, and essentially all of these other services that you're attaching to the VPC could not reach S3 because you can't transit through a VPC. We'll talk about transit VPC in a moment. But essentially here we've got now PrivateLink enabled S3 access or interface endpoints for S3, and you can reach S3 via the interface endpoints from all of these other services. So it's actually pretty awesome. Now you can build a hybrid S3 private connectivity from maybe your on-premises via a direct connect up through the VPC to an interface endpoint and then over to S3. Pretty amazing stuff. So you can reach those endpoints from anywhere outside the VPC now, as long as you build that routing. Okay, this is another exciting one. This is fast becoming my favorite service. And if you've seen me present before at some of the other reInvent sessions, Transit Gateway was my favorite service for the longest time. Now, Gateway Load Balancer, which we recently launched, is maybe a number 2 or probably even almost number 1 now. Let's talk about it. Again, QR code in the top right-hand corner if you'd like. Now we have basically some architectures from the archives here, and I'll go over this pretty quickly because these are the architectures you folks have been building for many years, like 5+ years now. And so essentially what we're hearing from customers is you'd like to deploy firewalls in line, for example, just like this, where we've essentially got routing inside a single VPC, and we're routing to a firewall, the firewall's then routing out to the public internet. And so you're essentially creating a bump in the wire here, and this firewall's in line. Now, with this, it is only an active passive because routing is only a single destination within the VPC. And so what we started to see was customers do this, and this is what's called a transit VPC. And the transit VPC is where you would start with maybe some VPN gateways or some VGWs, virtual private gateways, use IPsec and BGP to connect to these firewalls. And in this topology, different from the last, you could essentially have a centralized security VPC that could connect down to all of your other VPCs. And you could use this for north-south traffic, going from the internet to the spoke VPCs, or east-west, going from spoke VPC to VPC. And again, we have our routing that enables the connectivity here. And so what we then saw was topologies with Transit Gateway, where Transit Gateway was really giving you the ability to connect to up to 5,000 VPCs in a region and then peer across regions as well, which we'll talk about. But essentially, the topology that we saw here was customers were using appliances in line connected to a Transit Gateway and using routing and equal cost multipath, so ECMP, from the Transit Gateway up to a fleet of firewalls at the edge. And this was super interesting. It's actually quite an ingenious architecture that you folks came up with. So it basically allows you to have a scalable security edge VPC in this case. And we still see this a lot today. Also, I've got a bit of a bonus here for you folks. I kind of, myself and another gentleman coined this term, the ELB sandwich, where essentially what you're doing here is for outside to inside traffic, you're sandwiching a set of firewalls between 2 elastic load balancers. Now you probably use a network load balancer, not a classic load balancer, but this was another architecture to put some put a scalable fleet of firewalls in line in front of your web tier or something like that. Okay, let's talk about after. Now we have Gateway Load Balancer. What does it look like? Well, it's very similar to PrivateLink. So essentially what we're doing here is we've got a Gateway Load Balancer endpoint that we drop inside a VPC. And then we've got a Gateway Load Balancer that sits inside the services VPC. And it's very similar where PrivateLink has the network load balancer inside the the services VPC or the service provider VPC. And so essentially what this is allowing us to do now is have an auto-scaled fleet of firewalls on the south side of this Gateway Load Balancer and having the ability to drop that endpoint into many VPCs. And so traffic now looks like it's a bump in the wire through this scalable fleet of appliances. And so essentially, when you deploy this, you're going to be dropping that interface into a VPC and then using the Gateway Load Balancer, which encapsulates those packets in Geneve protocol and sends it on to the fleet of firewalls. Let's take a closer look. So essentially here, we've got 2 VPCs, and it looks very similar to PrivateLink. If you're familiar with those constructs, it's going to look very familiar. And so we've got our routing here, and essentially what's going to happen is the packet's going to come in via the internet gateway, hit the Gateway Load Balancer endpoint, get forwarded on to the Gateway Load Balancer. And again, at the edge there, we're using route tables, but in this case, we're using an IGW ingress route table. And so you'll notice the packet gets forwarded all the way onto the application instances. Now, the return path via routing inside the VPC, you've got a default route in that application subnet back to the Gateway Load Balancer endpoint. packets are going to go back to the firewall and then forward back on to the original destination. And so the beauty here is we're not changing the destination of the packet. We're forwarding the packets, tunneling in Geneva protocol, and sending it on to the appliances. And in this case, the appliance sees both directions of traffic, which is really important for when you're deploying appliances or firewalls. They like to see both sides of traffic. Otherwise, it might look like a DDoS or something. You know, if you're sending packets and not caring about the response, why would you be sending packets anyway? So it's good to see that response there. Okay, a couple of different architectures here. So what we can do is we can take a VPC on the left and encapsulate this in encapsulation A, for example, which is our Geneva encapsulation, or not ours, but it's public out there. We're just using it for the gateway load balancer. And so here you've got multiple VPCs all encapsulated and sending traffic to the same firewall fleet. And they all have their own internet access in this case, just like we did before. Now we can take that one step further here, where we've got a transit gateway and we've got an edge VPC that has a NAT gateway and internet connectivity. Packets come into the TGW, onto the gateway load balancer, and then back to the instances. And so this is for north-south inspection. We could also take that same topology and do east-west inspection. Now we could also combine north-south and east-west into one fleet if we wanted to. So there's a lot of flexibility with gateway load balancer and getting these appliances in the traffic flow, or becoming a bump in the wire in your traffic flow without changing that destination of the packet. And you could also take the NAT gateway and put it in the appliance or security VPC if you wanted to as well. Now we do have a lot of partners here. So we have our advanced security partners like the Checkpoints, the Palo Altos, the Fortinets, etc., that have appliances that work with gateway load balancer. That list is much, much longer now. We have analytics partners that are, integrating with gateway load balancer, orchestration partners, and then system integration partners like E+ as well. And so some of the key takeaways here, we're reducing complexity to deploy appliances faster in a scalable manner, supporting leading edge appliances within the gateway load balancer. So very cool and very worthwhile checking out if you're building things like those transit VPCs that we saw from the architectures from the archives. All right, now this leads us on to our next service. Again, QR code for you, AWS Network Firewall. So what we essentially did was take gateway load balancer technology and build our own network firewall for you folks to use. So you don't have to deploy your own firewall. And basically this is a native firewall service that runs inline. It's giving you control across layers 3 and 7 of the OSI model, and basically allows you to broadly inspect traffic. Now, what I'm interested in is the VPC architecture, but basically here you get stateful and stateless rules. You can do FQDN-based filtering, something you can't do with security groups, regex matching, allow drop alerts, and some logging there as well. Now the benefits here, pretty straightforward. It's a fully managed service. It's going to allow you to do those flexible deployments, fine-grained controlled, and we also have partner integrations for Network Firewall too. Now we get to the VPC topology. So basically here, we have the network firewall within our VPC, and we're routing just like we were before with that traditional model, having the active passive firewall, but now it's the firewall as a service, and we route through that service itself. Now, what we could do is basically use this with a transit gateway, have a VPC that has the network firewall, and route things through that centralized security VPC as well. So pretty cool. And so basically in this case, we're doing north-south traffic through that security VPC. Okay, this leads us on to some innovation that we've done around Site-to-Site VPN, and I will cover this pretty quickly. Site-to-Site VPN's been around for a while, but essentially when you're building a Site-to-Site VPN using AWS managed VPN endpoints like the VGW, you've got the VGW, the customer gateway, which is your router, you've got the public internet, and then we've got IPsec tunnels. Pretty straightforward. So here, what we've actually done recently is we've added a whole bunch of new encryption options. And I'll leave that there just there for half a second so you can grab a shot of the QR code. But we did add all of these encryption options that all of our customers were asking for, and these weren't available previously. So that's pretty cool. We also have tunnel initiator mode. The VGW can now initiate an IPsec tunnel, which is super important to some people where their site can't initiate. Now, what I'm actually doing here, it's a bit of a sleight of hand. but I'm replacing the VGW with the TGW, because if we use the TGW for our VPN termination, and it works pretty similarly to the VGW, except it attaches to many VPCs. However, we can do V6 inside our VPN tunnel now with the transit gateway. So that's actually cool if you're interested in V6, and I'm really interested in V6 these days. If anyone wants to reach out to me and chat about V6, please do. I can chat about V6 all day long. We're trying to figure out a whole bunch of new architectures where we can embed V6 here. And here's a QR code for this one as well. All right, we now have Direct Connect. And I think we're on our second last here. So we've got an exciting one after Direct Connect. But Direct Connect as a whole really is a straightforward service where we're allowing you to connect to an AWS POP or point of presence via what we call a cross connect. And the cross connect allows you to build a private virtual interface to a VGW or a public virtual interface to all of these public services and to any region as well. You can connect to any region's S3, for example, over our public virtual interface via this Direct Connect POP location. Now, Direct Connect as a whole, we can basically have multiple private virtual interfaces or public virtual interfaces. And here we're connecting to multiple VPCs. We could use a Direct Connect gateway and attach that private virtual interface to up to 10 VPCs. So it gives you a bit of scale there and means that you can connect one VIF to many VPCs. You can also connect across regions with Direct Connect gateway. And you could have VPCs in different accounts. So that's DX Gateway and Direct Connect. So pretty straightforward. Now, I would say before Transit Gateway, Direct Connect was my favorite service. So this is probably number 3 now, just because building hybrid architectures is something that is super important to some of our customers. Now, what we have now is the Transit Gateway, where we can attach a transit VIF, a new type of VIF for the Direct Connect, and we can actually attach that Direct Connect gateway to up to 3 transit gateways. And what that basically does is it allows us to have 5,000 VPCs connected back to the Direct Connect gateway. So it's actually pretty awesome. Now, you might wonder here, the cross connect is a physical cable. It's a physical port on a router. So what is a good idea to do is to build 2 for redundancy. So what we do have here is also the Direct Connect Resiliency Toolkit. There's a quick QR code as well. The URL is quite straightforward. It's like Direct Connect /resiliency recommendations. And this basically gives you a whole bunch of recommendations on how you can build redundant Direct Connects. I did a session back in 2015 called Double Redundancy with Direct Connect. I think it's still on YouTube, but it's still up to date today, believe it or not, because building resilient or redundant Direct Connects is still important to make sure that when that physical fiber goes down, you've got a secondary path. Now, Transit Gateway, I feel like we don't spend enough time on Transit Gateway just because it's such an immensely powerful and awesome service where essentially we've got multiple VPCs here, up to 5,000 per region, and we can connect to on-premises via Site-to-Site VPN. We've got our maybe our transit VPC here, and then maybe some Direct Connect via a transit VIF. So the Transit Gateway is this centralized hub for the region. Now, what we also did was we released Transit Gateway peering. So here we can essentially attach 2 transit gateways across 2 regions. And so if we just build this out, it's a new attachment type. It uses cross-region peering encryption. So these connections are encrypted across the AWS backbone. You can't peer within the same region though. This is really built for cross-region peering. And so what we can essentially do now is we can peer all of these regions together. And we've been pretty busy recently in that we've basically, we support this in many more regions. So there's a couple of points here about, we do suggest full mesh peering. We do suggest using unique ASNs when creating the transit gateway. We did start with a couple of regions, mainly out of APAC and the North American regions here, but we now support many regions. We also support some CloudWatch metrics as well. So you can basically build this global backbone of transit gateway peerings connecting all of your VPCs together, with each transit gateway having up to 5,000 VPCs. So the opportunities here for connectivity are pretty amazing. Now, we do realize that when you're building all of these routes, it's a good idea to get some visibility. So we did release Route Analyzer as well, worth checking out. Basically helps you verify transit gateway route tables. So you can validate your routing configuration and make sure it's you've got routing all the way through. And it helps you diagnose issues and that sort of thing. I have a really quick screenshot here of Transit Gateway Route Analyzer. There's a quick QR code as well. But the screenshot is kind of heavily redacted here. Probably worthwhile jumping into the console and checking out Route Analyzer yourself as well. But this is kind of a bit of a view on what that looks like. We do also have Transit Gateway Appliance Mode. That helps when we're connecting appliances to Transit Gateway. Check that out. It's basically going to keep traffic within the same availability zone. Definitely worthwhile if you're putting appliances in line in that transit VPC that we were talking about earlier. Now, lastly here, we've got AWS Outposts. And this is super exciting to me because I hear from a lot of customers, hey, I love AWS, but I wish you were in X or Y location. So let's talk about Outposts and how the VPC architecture looks like. So Outposts as a whole, we basically have a rack where we have hardware. And so it's basically the same technology that we use within the AWS data center. And it's essentially an extension of an availability zone. And so if we look at what the architecture looks like here, we've essentially got the region constructs on the left like we did before. We've got the outposts on the right. We're extending the VPC to the outpost. And so we now build outpost subnets on premises within your location. And we've got instance Y and instance Z here. We have route tables, security groups, network ACLs. All of those VPC functions that you use in the region can be used in the outpost as well. And this is immensely powerful. So you can basically build your own or extend your availability zone down to your own data center and use those same API calls. They're a little bit different in some cases, but the same API calls and IP addressing and that sort of thing. Now, what you can also do here is you can communicate back to the region. And so if we look at our route table in the outpost, we've got internet gateways, we've got all of the region level services on the left-hand side here, like VPC endpoints, transit gateways, VPC peering, VPN gateways, and we just build out our routes on the outpost route table to allow that connectivity. Now, the main reason you want to use Outposts is to connect on premises. And so we built this new construct called an LGW, or a local gateway. And the LGW essentially lets you route via what's called a customer-owned IP. It's like an elastic IP that you assign to the outpost up into the other workloads on premises. Now, a key takeaway here is you can route anywhere else as well. You're not limited to your own data center. Whatever routing you have in your data center applies, and you can send traffic from that outpost anywhere you'd like, and you can control that connectivity. Pretty awesome stuff. Now, we have a network reference architecture for Outposts. Check it out. There's a whole bunch more detail in there. I glossed over the nuts and bolts of how we stitch together that connectivity using what's called a service link, but dive in there and have a read. There's a lot of detail there to check out if you're interested in Outposts. Alrighty. So that brings us to the end of the session. I just want to thank all the folks that worked on all these services. We talked about Direct Connect, PrivateLink, Gateway Load Balancer and Network Firewall, VPN, and Outposts as well. So these are all networking services with a little bit of security that work with your VPC. And lastly here, we have a quick slide here on some details about our training and certification program. Definitely worth checking out. The networking part of this training and certification, we actually have the specialty exam worth checking out, and there's a whole bunch of courses there, but go check out our training and certification to get up to speed on some networking and other services with AWS. And that's all I have for time for you folks today. I'm Matt Lewis, Solution Architect here at AWS. Thanks very much for listening in today. Glad to be here. And don't forget to fill out the survey. Thank you.